Hello learners, welcome to this course on Embedded System Design using PIC16F877 microcontroller. In this tutorial, I will be discussing about on how to build a water tank level control system. So let us consider a simple use case where I have a water reservoir. From this water reservoir, we have to pump the water onto a water tank based upon the content in it. So in order to measure the water content in the water tank, we use two sensors, a simple wire type of sensors, one placed at 10% level and another one placed at 90% level. So these two sensors will give the data to a controller, based upon which the motor will be switched on to pump the water from the reservoir to the tank. So this is a simple use case. So we are going to do this automation with a slight modification. So in this example, what I am going to do is I am going to take a water tank which is connected with the two sensors S1, S2. So S1 is at 10% water level and S2 is at 90% water level, and I am going to use two motors, one for putting the water into the tank, which is M1 inlet, and another one for getting the water out of the tank, which is M2 outlet. So these motors can be used with a simple open close type. So thereby I can open the valve, the water can enter into the tank. Same way I can close the valve so that the water will not enter. Same way in case of an outlet motor, we can just open the valve, thereby the water will drain out of the tank, and just by closing it the water will not drain out. A simple motor can be interfaced for both inlet as well as outlet operation. So the basic theme here is, when the tank is empty, both the switches or sensors S1 and S2 will read 0. So it will indicate that the water tank is empty. So thereby we will switch on the M1 motor. So thereby the water will start filling up. As slowly the water increases, when the water touches the 10% sensor, which is S1, so S1 will read 1, S2 will read 0. At that time what I am going to do, still I am going to continue with the same condition. So M1 will be on, M2 will be off. So water will get into the tank. So the water rises. As the water rises and reaches the S2 level, which is 90% of the tank, so at this time what I do, I switch off the motor M1, that is inlet water into the tank, and I open the outlet from the tank. So thereby the water starts draining out. When the water starts draining out, what happens? The S2 will go to 0 and S1 will read still 1. So slowly the water is getting drained out. Once it reaches S1 and below S1, what happens? Both S1 and S2 will read 0, 0. So thereby again I am going to switch on the motor 1 inlet and I am going to switch off the motor 2 outlet. So this process will continue infinite number of times. So the basic idea here is, we are going to have a water tank where the water tank will get filled up. Once it gets filled up to a maximum level, we drain out the water. So this type of application can be done in a irrigation field. In a irrigation field, I can have the tank to be filled up. Once the tank is filled, then the water can be drained out to the crops. So once the tank becomes empty, again I can switch on the motor, thereby the water in the tank will rise, and once again it becomes filled, then again I can drain out. So such type of application we are going to build in this tutorial. So in order to do this process, we need to implement a state machine. So for implementing a state machine, we need to have an idea about the states. So I am going to use 4 states: empty, 10%, 90%, and an intermediate stage. So in this empty stage, both sensor 1 and sensor 2, sensor 1 is a bottom sensor, S2 is a top sensor. If both the values reach 0, which means the tank is empty, at that time what I am going to do, I am going to switch on M1. M1 is the inlet motor, M2 is a outlet motor. So I am going to switch on the inlet motor and I am going to switch off the outlet motor. So what happens? The water gets filled up. And also I am going to have a variable, two variables I am going to use. One is in and another one is out. So the in is used during the filling of the tank, out is used during the draining of the tank. So I am going to say in equal to 0. So slowly the water gets built up. So once it reaches 10%, I go to the next state. So the next state is where S1 reads 1 and S2 reads 0. So this is the stage where I have the tank to be with 10% water. So during that time also what I need to do, I am going to have the same condition. M1 will be 1 and M2 will be 0. Inlet motor is on, outlet motor is off. And I am going to have a variable in is turned to be 1. So this two process from empty to 10% and from 10% to 90%, it is an inward flow of water into the tank. So I am going to use the variable in. So once I do this operation, what happens? The tank gets filled up. Once it reaches 90% level, both S1 and S2 will read 1, which means it is almost full. The tank is almost full. So at that time what I am going to do? I am going to change the condition. So the inlet motor M1 is off, outlet motor M2 is on. And since it is an draining process, the water is going to drain out of the tank. I am going to initialize a variable out equal to 0. So when this happens, the water starts coming down. When the water starts coming down, my sensor will read a value S1 to be 1 and S2 to be 0. So during that scenario also, I should continue the same process. M1 is 0, M2 is 1, which means the inlet motor is off, outlet motor is on, and I define a variable out equal to 1. So once I go from this state, once the water level reaches below S1, what happens? Again it goes to S1, S2, 0, 0 state, which is an empty state. So again the same process repeats. So this is how a state machine is constructed for this application. Once we have developed the state machine, it is very easy for us to convert the state machine into a code. So let us look at the same state machine in terms of a table. If my S1, S2 is 0, 0, I am going to switch on the inlet motor, outlet motor will be off. For S1, 1 and S2, 0, this is on the filling up of the tank. Okay, so I have two conditions here, S1, S2 to be 1, 0. I have two states, 1, 0 here also is there, the fourth state is also 1, 0. So, but the second state is during filling up of the tank, and the fourth state using the draining up of the tank. So here in this filling up of the tank, still the inlet motor is on, outlet motor is off. Then once the sensor, both the sensor reach 1, 1, which means 90% tank is filled, M1 is off, which is inlet motor is off, outlet motor is on. Then while the water is draining out, there will be a condition S1 equal to 1, S2 equal to 0. At that time also, I am going to have the outlet motor to be on, inlet motor to be off. Now let us see the block diagram representation, how we are going to implement this. So we are going to use PIC16F877 microcontroller. I am going to use two sensors, a simple digital sensors. When the water touches the sensor, it will read 1. When the water is not touching the sensor, it will read 0. So simple digital type of sensor. So one placed at 10% water level, which is S1, and another one is placed at 90% water level, S2. So both the sensors are connected to RB0 and RB1 pin of your PIC16F877 microcontroller. Then I am going to use two motors, one for inlet and another one for outlet, in order to provide proper current to this motor and also to provide isolation from the motor to the microcontroller part. We use the motor driver IC. So the motor driver IC is connected through RC0, RC1, RC6, RC7 from PIC microcontroller. So this RC0, RC1 pin will be used for controlling the DC motor. RC6 and RC7 will be used for controlling the DC motor outlet. And the necessary supply voltage for the DC motor is given to this motor driver IC. So this part, upper part, it controls the inlet DC motor, lower part it controls the outlet DC motor. So to implement this, we are going to use the IDE, Integrated Development Environment, is Micro C Pro for PIC microcontrollers, and the simulator which you are going to use is Proteus 8 Professional Simulator. So now let us go and see the Proteus implementation. So in the Proteus 8, I am going to use the PIC16F877. So this PIC16F877 microcontroller is connected with the oscillator of 20 MHz crystal. So this 20 MHz crystal will be internally divided by 4, it becomes 5 MHz and will be used for instruction execution speed. And there is a memory clear circuit here. So MCLR bar is an active low signal. So by default this pin should be at logic high, so that is why it is connected to a VCC. Whenever I close the switch, what happens? Logic 0 will be given to MCLR pin, thereby reset operation will take place. So this is a simple reset circuit for our microcontroller. Then we have connected two switches, which is nothing but the sensors. RB0, one switch, S1 bottom, and another switch to RB1, S2 top. So we have connected a resistor to the switch because by default this pin will be at logic 0. When I close the switch, this pin will go to logic high. So that will be considered as a valid state from 0 to 1 transition. And we have used two more DC motors, one for inlet and another one for outlet. M1 is for inlet and M2 is for outlet. So RC0, RC1 is given to the in1, in2 pin of your L293D motor driver, and these two pins RC0, RC1 will be used for controlling your inlet motor. Same way RC6, RC7 is given to IN3 and IN4 of your motor driver, and these two pins will be used for controlling your outlet motor. And the motor DC motors are supplied with the necessary supply voltage of plus 12 volt. So that is how a circuit is built for your water tank level control system. Now let us go and build the embedded C program for it. So while building an embedded C program, we need to convert our state machine into the program. So I am going to define certain functions, one for water inlet. So for water inlet, I am going to use port C, 0th pin as 1, port C first pin as 0. So the motor will rotate in clockwise direction. Same way water outlet, I am going to use port C.F6 to be 1, port C.F7 to be 0. So again the outlet motor will run in clockwise direction. Then I write a program or subroutine for inlet stop as well as outlet stop. So which is for stopping the inlet motor and outlet motor. So in both cases F0 and F1 are set to be 0. In outlet stop, F6 and F7 are set to be 0. So these are some of the functions which you have defined. Then I am going to define two variables, in equal to 0 and out equal to 0. Then in the main program, first step is we need to set the data direction for your ports. Since we have used two motors to port C, I am configuring the port C as an output port. So how we are going to do that? We use a data direction register TRISC. TRISC equal to 0x00, where this 0x represents it's a hexadecimal number. So setting 0 to the data direction register will make the port to be in output port. So in TRISC I have connected two switches or two sensors with two RB0 and RB1. So these two are need to be configured as input port. So I use 0x03, 03 in the sense 0000 0011. So RB0 and RB1 pin are configured as input pin. Then intcon equal to 0x00, which is used for disabling all the interrupts. Then in a while loop, I am going to check whether my two sensors are 0. So one is at F0 another one is at F1 of port B. If both the sensors are 0, which means the tank is empty. In that case, I am calling water inlet. So water inlet program or water inlet function will run, which make the inlet motor to be turned on. So the water will start flowing into the tank. So during the filling up of the tank, I am going to check whether my port B F0 is 1 and port B F1 is equal to 0, which means now the tank has been filled to 10% water level. In that case, I am changing this variable from in equal to 0 to in equal to 1, which means I am indicating it as 10% water is filled in the tank. Then in the next while loop, I am checking whether it is at 10% water level. So F0 equal to 1 and F1 equal to 0, and whether it is at 10%. How to check whether it is at 10%? By checking the variable whether it in equal to 1. So in that case, again I am going to do the same thing. Water inlet, water will get into the tank, and outlet is in stop position. So while filling up of the tank, I am going to check whether the water has reached 90% mark. How to check it? The two sensor values, whether it is reading 1. Okay. Port B dot F0 equal to 1 and port B dot F1 equal to 1, and whether it is in a filling state, which is in equal to 1. In that case, once the water reaches 90%, I am going to say that the incoming process to the water tank is going to be completed. So thereby I set the in to be 0. Then I check in the next while loop whether my water is at 90% level. Okay. So again by checking port B dot F0 equal to 1 and port B dot F1 equal to 1, and whether my incoming process is completed. If that is the case, I am going to switch on the outlet motor. Inlet motor will be stopped. So while the outlet motor is on, the water will be drained out. At that time, I am going to check whether my port B dot F0 is equal to 1 and port B dot F1 equal to 0. If that is the case, the output process is on and it is below your 90% mark. The water level is below your 90% mark. That is indicated by out equal to 1. So once the water gets drained out, once the sensor goes below your 90%, I am going to check it by port B dot F0 equal to 1 and port B dot F1 equal to 0. Still the same condition exists. Water will be outlet and inlet will be stop. So while the water is getting drained out, I am going to check whether it has become empty, whether it has gone below 10%. How to check it? By port B dot F0 equal to 0 and port B dot F1 equal to 0. If that is the case, my output process is completed. The draining process is complete. So I set out equal to 0. So my in will be equal to 1 when the water level is rising, and when it is between 10% to 90%, my in will be equal to 1. Same way, my out will be 1 when the water level is draining out and the water level is in between 90% to 10%. So this is the two conditions which I am trying to set here. Once the program is done, we need to build this program to convert it into a hexadecimal file. So I can use this build option. So when I build this program, it gets compiled and hexadecimal file will be created with name water underscore tank underscore control dots. So here you can see the hexadecimal file. So in the output files, you can visualize there is an hexadecimal file created. So this hexadecimal file which we try to put into the Proteus environment. Now let us go to the Proteus environment. Right click on the microcontroller, edit properties, load that hexadecimal file. So hexadecimal file is water underscore tank underscore control dot x. So I am importing the hexadecimal file into the microcontroller. Set the oscillator frequency to be 20 megahertz. Okay. So now we have dumped the program file into the program memory of your PIC microcontroller. Now we have to check whether it is working properly or not. In order to check, I am going to press this play button. When I press this play button, you can see the inlet motor is running. So which means the water is getting filled up. So when the water is getting filled up, once it reaches 10% level, the sensor S1 will be activated. So I am going to activate this S1. So sensor 1 is activated. So still the inlet motor is on, outlet motor is off, so water is getting filled up. So after 10% it slowly increases. So when the water reaches 90%, the S2 sensor will be activated. So when the S2 sensor is activated, you can see the inlet motor has stopped and the outlet motor has switched on, which means the water is getting drained down. When the water is getting drained down, what happens? The S2, the water level goes below 90%. So S2 will become 0. Okay. When the S2 becomes 0, once S2 becomes 0, still the motor M2 is in on state. So the water is getting drained out. So once it falls below 10% water level, the S1 will be 0. You can see. Then the motor 2 is stopped and motor 1 starts running. So this process continues. Again, the water is getting into the tank. Again, when S1 is activated, again still the same process. Inlet of water continues. Then S2 outlet water activates, thereby draining of water happens. Then S2 again deactivates. Then when it goes below S1, the inlet motor runs. So this process continues. So thereby the water gets filled up into the tank. Once the tank is full, it will be drained out to the field. Then again, once the tank becomes empty, again the motor will switch on and it will activate your water into the tank. So this is how a simple water tank level control system can be built. So in this tutorial, I talked about how to automate a water level control system. Thanks for watching. Please subscribe for more technical learning. So you can get the code from this GitHub repository. So there I have included 3 codes. One is a C file which you can use it in your Micro C Pro for PIC. You can create your own project, import that C file into that project, and you can build the X file. I have also given the X file, and also I have given the project file in your Proteus environment. So you can go to this GitHub link and you can download the code and you can start working on this program. Thank you.